This is Austin York,
This is Taylor Tharp.
and this is our experiment for analog electronics. It is a reverse Avalanche oscillator that goes into this mixer here. We have 3 oscillators on our breadboard, with the last one having a larger capacitor for a different pitch. If you want to go into the mixer, Taylor.
Yeah, so the basic setup is that each oscillator has its own output, which is going to a TS connector, which is just a hot signal and a ground. So we have all 3 oscillators going to 3 different channels on this passive mixer here. So what we're going to do is turn on the power supply here, the DC power supply. Our oscillators operate between 12 and 18 volts. We'll have this one set to 13. And then Austin will demonstrate some adjustments on the pitch, and I'll do some adjustments on the volume of the mixer so that we can see how the voltage adjustment on the potentiometer changes the pitch, and we'll be able to mix those signals together.
Right, and it'll be kind of hard to see in this video, but the light from the LEDs here will it'll coincide with the pitch of the frequency, but I guess that'll be seen better in the next video.
It will. Yeah, we'll do a close-up video after this to explain that. So we'll go ahead and turn our DC power supply on. There we go. You can already hear the oscillators coming in. So Austin, go ahead and give us some demonstration on the pitch.
Here's P1.
Ooh. There we go. So we can hear the clicks turning into a single pitch, and that's the reverse Avalanche oscillator releasing. And once it releases fast enough, it creates a tone. Then we'll bring in the second oscillator here.
Here comes number 2.
Nice. Now we'll go for number 3. All right, you can hear that low oscillator coming up.
Very low. Let me try to adjust 2 a little bit more. That's kind of like a eerie, like a
It is.
tritone or something.
Yeah, that's a basic overview of how the reverse Avalanche oscillators sound, how we have a basic setup here with this mixer. And like we said, in the next portion of the video, we're going to do a close-up and explain details about the circuit and how we put everything on the breadboard. Okay, here's a close-up video of the reverse Avalanche oscillator circuit on the breadboard. I'm just going to go over one portion of the circuit because the other 2 are exactly the same. One has a larger capacitor value to allow for lower pitch. So the voltage supply comes in here on this power rail, and then that connects to a 1K ohm resistor, which then connects to this cable, which goes out to a potentiometer. And that's what I was adjusting earlier, which changes the voltage into the transistor, which is what allows the pitch to be changed. And that potentiometer comes back out here, and that connects to the collector leg of this transistor. And this is in reverse. This is a reverse Avalanche oscillator. So this is an NPN transistor. And then the center leg, the base leg of the transistor, is connected to a 1 mega ohm resistor, which then connects to ground. So in series with the output of the potentiometer, the collector leg of the transistor, in series with those 2 is the positive leg of this capacitor. And then that capacitor, the negative leg of that, connects to this cable, which then goes back here to ground. And then on the emitter leg of the transistor, it is connected to the positive leg of this LED. And then that LED is connected to the same series trace that the negative leg of the capacitor is connected to, and this ground here. And then the last thing in this circuit is this 100 kiloohm resistor, which is connected in series with the positive leg of the capacitor, the collector leg of the transistor, and then this output of the potentiometer. And then that connects to the output, which will follow this here, goes to this alligator clip, and then that goes here to this alligator clip, which then connects to the input, the tip of this TS connector, which is then connected to the back of this mixer. And then the ground of this TS connector, this green alligator clip, that just goes back to the negative ground rail, which is then connected to the negative lead of the power supply. And so I'll turn the power supply on just so we can see a close-up of the LEDs as they're functioning. I'm not gonna turn the speaker on since we already got a sound demo. Here we go, we'll turn this on. See this come on, our LEDs here. And so these are currently functioning, and as I drop the pitch on this first oscillator, we're gonna see the LEDs start flashing, because that, there we go, actually coincides with the pitch. It's changing a little bit, probably because of the frame rate of the camera, but you get the idea. All right, so we hope that this video gave you a good idea of how the reverse avalanche oscillators work. We were able to show a close-up video of the breadboard and the oscillators on that, and how we hooked those up to the mixer, and gave, I think, a pretty good demonstration about the functionality of those oscillators.
Right, and one thing that we learned in this experiment is tying back into what we learned in class, is that we learned that a transistor can be used as an amplifier or as a switch. But as we've seen and has displayed in this experiment, that it can also be used as an oscillator. And I think it worked pretty well in our experiment, and I hope that y'all saw that the same way.
Definitely, yeah. So thank you, Professor Babakir, and we're looking forward to getting some feedback on this project.
All right. Thank you, sir.